Welcome to our lesson today about the properties of water. We're going to look specifically at the heat capacity and structure of water and what makes it so special. Our objectives, I want you to understand how water absorbs large amounts of heat, and also to understand the structure of water and how it affects its density. So, before we begin, think about a day on a sandy beach by the water. As you walk on the sand, you notice it's hot on your feet. But then when you walk out to the water, it's cold. Both surfaces are exposed to the same amount of the sun's energy. However, one heats up more quickly. But then come evening time when the sun goes down, do you notice the sand gets cold, but sometimes the water is still warm? Well, this comes to the unique properties of water and its heat capacity. Water is considered a universal solvent, which means that any type of material can be dissolved in water. So what makes this so unique is that the molecules in water, these little things in the corner, they form bonds with other molecules and keep changing. They're able to hold hands with different molecules. But they're also able to grab onto other things. If we pour salt into water, the water molecules are able to grab onto the salt. And so they can connect with many other materials and many other molecules. Water doesn't have to maintain a continuous connection like most things, like for example, the molecules that make up your desk or make up metals. They have connections to each other that are made and final. They don't change. Water molecules can keep shifting their connections. So they can make connections to many other materials and many other molecules. This is important because the loose connection between each water molecule allows it to hold a lot of heat. And so what will happen is water can absorb a lot of heat and slowly release it. And this is super important because water can control the amount of heat in our bodies, in cars through your radiator, and in oceans. So water can take in a lot of heat and slowly release it. So here's your first shout out. Water is known as a blank solvent. There's a term we used earlier, and it refers to how water is able to absorb many different types of substances. If you said universal, you'd be correct. Next question. Water molecules can control the amount of heat in. So we talked about water molecules absorbing large amounts of heat and slowly releasing it. What are some examples of that? If you said lakes and our bodies, or oceans, you'd be correct. So when it comes to water's molecules and their very loose connections to each other, water temperature rises and falls very slowly. It doesn't heat up as quickly as sand or metal, but it also cools down very slowly as well. So it doesn't change temperature very quickly. It holds that temperature for a long time. And what will happen too, as water drops in temperature, when it freezes, it actually becomes less dense. That's why ice floats on top of the water. So what you see is that water, the way it holds in heat, is that it actually circulates. As it cools, it rises and floats on top of the water. So that's why when you touch the surface of a lake, it's cold, but as you plunge your hand in deeper, it gets warmer. And as it heats up, it sits at the bottom. But then at nighttime, the water starts to cool off again and that heat rises back up. So ice and cold water floats above warm water. And that's how lakes freeze in the winter, but the water beneath is still warm and protected, allowing fish to still live in it. So why is this important? Well, if we think of our sandy beach, during the day, the sand is warming up and the breeze is carrying cool air off of the lake and circulating it around. The lake is still absorbing heat, but it's not releasing heat. It's releasing the cold water on top, and it's cooling the land. That's why you get a cool sea breeze by the water. But then come nighttime, the cold air off the land is blown out to sea, and the warm air off the water, as it rises, gets blown back to the land, causing the air to be warmer. and that's how water regulates our climate. So, for your homework, I want you to describe how sand and water have a different heat capacity and submit that on Edmodo.